Let's learn how to graph some simple tangent functions. First, notice that this tangent has only an x in the argument or parentheses. One way to graph one period of the tangent function for that case is to just memorize these numbers. The tangent graph goes from negative pi over 2 to pi over 2. And if you plug all these numbers in a calculator, you'll find out that two of them are in error or don't exist because the tangent of those values is non-existent. Now, when you go to graph these points, the two non-existent values for y correspond to vertical asymptotes. The other 3 points you can plot. Remembering that a vertical asymptote is a line that a graph never crosses but gets infinitely close to, we can draw in a curve, and there's our tangent. But what if the argument isn't just x? What if there's a half in front of the x or any other number? But we're going to take the x values that we would have normally used, and we're going to divide them all by whatever number is the coefficient of x, in this case a half. When you divide them all by half, you get these results. I recommend hitting pause and confirming that I did divide by half correctly. And now we're ready to plug those numbers into the calculator, graph them with our vertical asymptotes for the non-existent y values, plotting the other 3 points as normal, and then drawing a curve that goes through the points, but also takes into account that the asymptotes are lines of approach, and there's our graph. What if there's a number added or subtracted from x? That's going to shift our tangent function to the right or left, depending on whether it's add or subtract. Take the normal numbers you would use for tangent, from negative pi over 2 to pi over 2, and do the opposite of whatever is inside the argument of the function. In this case, we're going to add pi over 4 because we're subtracting pi over 4 from x. These are the results that I got when I added pi over 4 to everything. I recommend hitting pause and doing the math yourself. And once you have your shifted x values, plug them into the function, graph the asymptotes, graph the points, and draw a curve that goes through everything and approaches the asymptotes. Thank you for watching.